In this video, I'm going to show the derivation of the loss function in logistic regression with respect to each weight and the bias term. So here's the problem setting. We would like to start from the loss function, and then we would like to get the gradient with respect just to a single weight wj. So first, let's start with the loss function. And then the first thing that we do here is that we take this derivative symbol into the square bracket such that each summation term now have this derivative symbol. We can derive them separately, in other words. Okay. And then next we see that y is a constant. So we can move this to the front. Okay, you see that y becomes there, and y minus y becomes there. Now, the derivative of log function is 1 over that thing. Okay, so if we have log z, for example, the derivative is 1 over z. So this thing here goes to the front, 1 over sigma wx plus b. Here we have 1 minus sigma wx plus b, but because remember this 1 over something, so it goes down there. Okay, but do not forget that once we do this derivative of log z is 1 over z, we still need to derive the z. That's why we still have this thing here, the derivation of sigma wx plus b, and then here the derivation of 1 minus sigma wx plus b. Now here, let us focus on this part. Here, if we take the derivative of this thing here, 1 is a constant, so the derivative with respect to wj equals 0. Derivative of wj for the constant 1, this equals 0. So 0 means the derivative wj for the sigma wx plus b. Okay, that's why here you see this thing here, we only left with minus wx plus b. And then we can move the minus to the front because originally it was minus, and minus becomes plus here. And then basically I think I did nothing else here. Okay, so that's all up to here, and then we haven't done anything with the first term here. Now, this is from the previous slide, and then we simply rearranging the terms. So we put this here outside the square bracket, and then inside the square bracket, we have this thing here, we have that, and then we take the minus out. So here from positive becomes negative. Okay, so that's all for this step. Okay, so here's from the previous slide. And we know that the derivative of a sigmoid function is the sigmoid function itself times minus 1 minus that sigmoid function. Let's apply this to derive this part, especially this sigma function. So, like I've said before, first rewrite the whole sigma function and then write 1 minus that sigma function, and then according to the chain rule, after we derive the function, we still have to derive the inside. That's why we still have the derivative of wx plus b with respect to wj. So now in this part, wx plus b, if we expand that part, it is w1 times x1 plus w2 times x2, that up to wj times xj, that up to plus the bias term. So if we take the derivative of this function with respect to a particular w, the result is just that particular xj. Okay. And then if we take the derivative of wx plus b with respect to b only, we will have the constant 1, right? Because this is 1 times b, so the derivative with respect to b equals 1. But right now we have xj. Okay, and then we cancel out these terms. This cancel out with that. So we are left with just minus y minus sigma wx plus b times xj. And then we multiply the negative inside. So this becomes the final result. So this is the derivative of the loss function with respect to a particular wj. Okay, so uh, those are the details of the derivative, and then in the next page you can see the complete steps of the derivation. So thank you for watching, and that I hope that helps you to ensure yourself that this thing here is really the derivative of the loss function with respect to weight wj. So thank you, and that's the end of this video. The final result.